Hey guys, welcome to another video. Today, another question from the Nice Question series. Today's question comes from the advanced syllabus from the School of Killara 2023 trial paper. It's a nice question from the topic of continuous random variables. I think it's the last question in the test. It's worth about, 6 marks? So quite chunky for a 2-unit question. So it's in 3 parts. Nice question. So before we dive in, guys, as always, if you please haven't already done so, subscribe to the channel, like the video, and tell your friends. All right, guys, let's dive right in. So, continuous random variables, right? I like these questions, especially when there's a context piece to it. So, let's have a look. So, from Killara, consider the function now. Okay, they gave you a function to begin with. Okay, part A just says differentiate, and then use it to integrate. Okay. And then chocolate bar manufactured produces bars between those two. That's a low limit. That's a high limit. Probability density function. Okay, cool. So you got this. Okay, and then 0 thereafter. Okay, pretty straightforward. Show that k equals this. Okay, it is known, right? The question tells you, right, that it is known that probability that, and then show that the median exists between 40. Okay, all right. Let's start. So, part A, right, looks to be differentiator. So if I sort of said, let me maybe articulate like, looks like it's product rule, right? That's U and that's V. So maybe I'll do that first. So U dash is 1 and V dash derivative of that. Now, negative X, right? So it'll be negative E K minus X. Yep. Where therefore F dash X equals to U dash V, so 1 times E K minus X plus, now V dash is negative, so minus V dash U, so E K minus X multiplied by X minus 38. Now, looks like it's factorizable, right? I can take that and that out. So then K minus X, what's that? 1 minus X minus 38. Now this is good, and you'll see why when I sort of conclude with the next step. Put the bracket first, right? Comes 1 minus, so it'd be like 39 minus, you know what? Just to make my next step easier, just gonna simplify this inside here to be, what was that, 1 minus X plus 39. That's like 39 minus X, right? And if I sort of factorize a negative out, it would be X minus 39 like that, right? Yep. So I'm going to factorize a negative out. It becomes negative bracket X minus 39 E K minus X. Now, therefore, F dash X equals that. Perfect. Yeah, let me check that. Great. Now, so I'm going to write the derivative, right, of the function, which was, what was it? X minus 38 times E K minus X equals to minus X minus 30. Put a bit of spacey because I'm intelligent, right? And I know where I'm going to go. E K minus X, right? That's the answer. Now, the question says, can you please integrate that, right? Which looks exactly the same as that. So once I've differentiated it, what I do is I basically integrate both sides, dx there, and I integrate that dx, right? It's important because the integral of the derivative sort of mutually cancels out, right? And you get the expression back. So you get X minus 38 E K minus X equals to now negative of the integral. Right, which is great because then all I got to do is chuck the negative over and I got it, right? And plus C. Right? So let me just write that a little cleaner there. Yeah, so therefore, the integral of x minus 39 ek minus x dx equals to negative of x minus 38 ek minus x plus c. Yeah, check that. Looks good. Yeah. Guys, that's my answer. Yeah. How's that? Pretty straightforward so far. 2 marks for that integral. I'm just gonna move this down here. I'll most likely need it, right? Let's have a look at part B. Now, chocolate bar has it's distributed between 39 and 44. It's got a probability density function of that. Show that. Now, if they say nothing else, right, I'm going to use the total probability, so the concept or rule where if I integrate from the lowest value to the highest value of any probability density function dx, right, that should be 1. Yeah, total probability, right? So this is key, right? So just going to box that. Yeah, make that a rule. Yeah. Now, with that in mind, so in this case, right, A is 39, B is 44, and I'm just going to integrate this as a function, right? Because it's 0 otherwise. And then hopefully when I do that, I can find the value of k, right? So let's have a go. I'm just going to come over here. Part B. So integral of 39, 44 of the PDF, right? The probability density function, k minus x dx, right? Now equals to, okay, give me 1 second. Okay, now the beauty about this now is that it's really easy in that I've already got this integral, right? Yeah, that was part A, yeah? So what was the answer? So I've already integrated it. I don't need to do anything fancier. Negative, okay. So that becomes negative x minus 38 ek minus x, right? And the limits are 44 and 39, right? This is 0. This is 1. So then that gives me 1. So I actually don't need that double equal sign there. Yeah. So let's see. I mean, for ease, I'm just going to throw the one negative on the other side and sub in my limits, right? So 44 minus 38 is what, 6 ek minus 44 minus 1. So then only 1 then. Ek minus 39 equals to negative 1. Yeah. Now, okay. How can I solve this? Let's see. Now, k minus that, k minus that. I think I'm factorizing out. Maybe I'll factorize this guy out, right? Yeah, factorize that out from both of them, right? So see if I can factorize it out from that. So I get, now, to illustrate what I'm going to do here, right? It's like saying if I had like let's say if I had E5, 6E5 minus E2, right? I'd factorize E2 out, right? Yeah. So it becomes like 6E3 minus 1, right? Maybe I'll do that. I'll factorize K. Which one's bigger actually? This one. This one's smaller, right? Yeah, this one's bigger. So always factorize the smaller one out, right? So in this case, factorize ek minus 44. Yeah. You definitely get minus, oh sorry, you get 6 minus. And how much bigger is it? It's like 5 bigger, right? So it should be E5. Now the test is when I rainbow 6 times this, perfect. 6, this guy times this guy, add that. Yep, perfect. You get that? Now, equals to minus 1. Let me see, how do I solve this? So I think I just divide this over, right? So I get ek minus 44 equals to -1 all over 6 minus e5. Now let me have a quick look at what I want to prove. See how they swap that around? e5 minus 6, right? So I'm on the right track. I just gotta, yeah, so what I'll do is, see that negative? Yeah, I'm just gonna basically swap these around, get rid of that negative, right? And at the same time, remove the e by logging both sides. So it becomes like k minus 44 equals to ln, swap that around, so it becomes like 1 over e5 minus 6. And then I think what they did was they reciprocated that and brought the negative power. That's what they did. Reciprocate, okay. Okay, so they did 2 more steps, right? So first thing they did was that they expressed this as e5 minus 6 to the power of -1, and then brought the -1 in front, right, using the log laws. And then secondly, they brought 44 over. So you can say therefore, oops, k equals to 44 minus ln of e5 minus 6, which is exactly what they want. Yeah, I think that's a sufficient working for us to conclude that way. Yep. How's that, guys? So we use basically the total probability rule to make that happen, yeah? Where the sum of all probabilities from the limits of 39 to 44 in this case gives me 1. Easy. Now, next question. What are they trying to say? It is known that probability between the lowest number of 39 to 40 is less than 0.3. Show that the median weight of the chocolate bar produced is between 40 and 41. Okay. Yeah. So if you think about what this question is trying to say, right? Yeah. So, like when you do cumulative probability, right? This is 0, this is 0.5, and this is 1, right? Yeah. If I do cumulative, this is known as the median, right? Yeah. And that's total, right? So what I want to show right now, it's telling me, right? The first fact is saying between the values of, oh, sorry. So let me move this over a bit. Yep. Between the values of 39 and 44 in this distribution, right? Yeah, that's total probability. So it's saying between 39 and 40, right? That's 0.3 there. Or sorry, yeah, less than 0.3. So what I want to prove, and maybe it goes, show that the median exists between 40 and 41. If I can show that 41 is over here, then the median exists in between. Does that make sense? So if I can show that cumulatively, right, from 39 to 41, right, if that number, whatever that number there, if that's bigger than 0.5 and 40 was less than 0.5, the median must sit in between. In other words, what I need to show, right? Yeah, show that the integral between 39 and 41 of the probability density function, I want to show that that is greater than 0.5. Yeah, the moment it's greater than 0.5, right? This sits above. I already know that 40 is below. Therefore, the numbers between 40 and 41 must capture the median, which sits in the middle, right? So this is the game, right? This is my point. So maybe I'll label on this side, right? That there, that's the median. Yeah. All right. So let's show this, right? This is what I want to do. Yeah, that's my question. So let's try it. Yeah. So once you figure that out, that's probably the hardest part because then everything else is just algebra. So you go limit 39, 41 of the function. Yeah, knowing that I already found k upstairs, right? So I probably need to sub it into my calculator. So I'm just looking at the function here, x minus 39. Okay, cool. You know what? I'm not going to fit it here. Let's just move it to, cool. Okay. All right, so I know the integral for this, right, was negative x minus 38, ek minus x. Now, I have to prove that the limit here is bigger than 0.5, right? So it's just a matter of punching it into your calculator, I guess. Now, did you guys know, and I don't know whether I've mentioned this in the past, when you do negatives, right, it actually flips the limits, right? Because if you think about it, right, when you sub the limit in, it's top minus bottom. But when you have top minus bottom with a negative in front, it basically looks like bottom minus top, right? So mathematically, you can actually switch these around, right? Just make sure limit subbing a bit easier. So in other words, get rid of negative, sub in 39 first, so it becomes e k minus x minus, and then sub in 41, which is 3 e k, oh, not x, right? So that one there is 39. That's k minus 41. Okay, so then when I plug in my k value, what's my k value? I'm just going to borrow it. You know, I'm just going to do it like this. Get a nice green highlight and then put in my pen. Plug it into there. And there. Yeah, the moment you do, now let me just check that I got the right working out. Yeah, that looks perfect-ish. 41 minus 38. I think the solutions are wrong. They have a 2 in front. Okay, I got a 3. 41 minus 38 is definitely not 2, is it? It's definitely 3, right? Yeah, I think the solution's wrong. In that case, I might need to punch it in manually. Okay, let me do that now. So if I do sub in that minus 39, I'll get like E44 with it. 44 minus 39 is 5 minus ln E5 minus 6 minus 3E. Now, if I sub in 44 minus that, that's 3 minus ln E5 minus 6. Right, just gonna punch that in. Let me see if that's similar to what they had. They had minus 2, 3, and 1, 5. Okay, I'm hoping then the question works because I'm pretty sure that's 3, right? Guys, can you check that for me? Leave comments. 41 minus 38 is 3, right? Yeah, I don't think I did it in the solutions. It's just 2, so I'm a bit nervous. So, okay. Let me repunch this in then. 5 minus ln E5 minus 6 minus 3 times. I think if anything, it will be bigger, right? So I think the question will still work. Just the answers might not be exactly the same as the actual solutions. 5 minus 6. Yeah. I mean, the answer still works, right? It's like 0.619, right? Which is perfect because it's bigger than 0.5. So you can say, therefore, the probability of the variable x between 0.3 and 40 in the question is given as less than 0.3. By the way, the answers say less than 0.5, so 2 things wrong with the answers. So 2 things wrong with the answers. First one is this, and I think this one here in the answers it says 0.5. It doesn't matter. So that's less than 0.3, and we just proved that the probability was not 0.3. Why did I put 0.3 here? I think I was saying 0.3. I wrote 0.3. Oh, it should be 39. And the probability between 39 and 41 is greater, also greater than 0.5. Yeah. So one's greater than 0.5. Theoretically, I think what they meant was they wrote 0.5 here because that's the concept, right? One's smaller than 0.5, the other one's greater than 0.5. Therefore, median exists between x between 40 and 41. Yeah. Guys, how was that? So this question was nice, right? Just slightly different. I like the context, right, with the chocolate bar, etc. Not that it matters, but first question, they basically used calculus for you to integrate an expression. Theoretically, you could have integrated that without finding a derivative by using reverse chain rule, but there it is. Secondly, actually, no, that's a lie, right? You couldn't integrate that with reverse chain rule because there's an X there. So I'm glad they gave you then a derivative to work with to do part A. Part B was really easy. Total probability, integrate it equals to 1, right? Get K, and then use K to pop it into C, where to find the median, we had to show that between the lowest value of 39 and 40, right? That value was less than half. If I found from the lowest value to 41 was bigger than half, then the median has to be in there somewhere. That's the concept, guys. How was that? Hopefully that was good. Like the video, subscribe to the channel, and tell your friends. Thank you.